Many people have asked me, what is a city digital twin and how can I benefit from it? Well, my name is Tom de Vries and I'd like to introduce you to the citywide infrastructure digital twin in 10 minutes. Infrastructure digital twins have become possible due to the convergence of reality modeling, GIS, mapping, building information modeling, geotechnical data, mixed reality, IoT feeds and so forth, enabling an immersive and holistic view of infrastructure assets. A digital twin incorporates different types of data repositories: engineering data, operational data, and data from mainstream information systems. The infrastructure digital twin bridges the physical and virtual worlds. In other words, the digital twin becomes a virtual replica of the physical system, but the two are connected through data flows. Infrastructure digital twins are not just about operating the infrastructure systems. They are useful in all stages of the life cycle, from planning to design and in construction as well. And it's a federated and open approach. There are multiple owners of the data in a city. The data typically exists in departmental silos, and it is impossible to migrate all of these silos into a single data store. But it is possible to connect the systems together, to create automated processes where changes to data are managed and synchronized between different systems. And rather than try to create a single system, we create a single view into the many systems. And this single view is used to generate insights based on the combined view of the data. And this is the essence of a digital twin. The digital twin exists by virtue of continuous capture and consumption. Change over time and federation of information are among the most crucial differences between a 3D model and a digital twin. And it all starts with digital context. For a city, this might include a reality mesh automatically generated from photos and LiDAR. It requires scalable processing capabilities to handle the large data sets typically needed for full city coverage. And it's not just about the above-ground infrastructure either. Here we see an example of using a street opening as an opportunity to create a reality mesh of the subsurface utilities. Using techniques like this, combined with existing GIS data into the digital twin, can improve understanding of the surface environment. But it's not only about the digital context, of course. It's about using the digital context to display the rich semantic information that is found in CityGML, GIS data, BIM models, and sensor networks. Different asset classes each have their own data sources, all in a variety of vendor formats and open formats. Bentley's Open Cities digital twin federates and aggregates the data and makes it available to support the asset lifecycle, starting with planning and communications. Here you see an example of how a digital twin is used to communicate new developments with the public. This works on the web, on mobile, on tablets, etc. I call this crowdsourcing for infrastructure. BIM models, CityGML and reality data all combined. Moving forward to design, what if we could start our designs in a real-world context like we do over here, instead of using traditionally blank pieces of paper? Now we can immediately see the impact that our design makes in the real world. In construction, here's an example of how a digital twin is used to review the daily progress of our construction project in a city, leading to reduced overruns and less disruption for surrounding buildings. When we merge this with IoT data, we have an operations example here where we're bringing in a direct connection with sensors and SCADA systems, showing the water column and velocity in the river in Trivia in Portugal. That is today. Now we move forward 1 or 2 days and use different data sources like weather forecast, tides, wind, etc. to model the predicted flow and water column height for the next 2 days. Early flood warning using a combination of ET, OT and IT. And now I'll take a few moments to explore how digital twins are used in the specific workflows for planning and visualization, stakeholder engagement, and simulation and resilience. What you're seeing is how Gothenburg uses the digital context of the city to visualize and plan a new 8-kilometer tunnel under the central district. They linked in data about the 3 new stations, including renderings of what the station would look like. Since this is buried infrastructure, there's a slider to control the transparency of the surface layers to easily see the tunnel. In Norrköping, they used the digital twin to capture urban planning ideas directly from citizens. The digital twin provides a fast, easy and visual way to successfully communicate, promote and share city projects in an interactive way to gain citizen buy-in and attract investors. Urban flooding is one of the most destructive and costly natural hazards. City digital twins can be used to do a risk assessment, plan risk mitigation strategies, and visualize the results of flooding in a city, all to improve the resilience of the city. You can't stop the rain, but you can plan ahead to minimize the impact and prevent damage to people, property, infrastructure, cultural heritage, and the environment. A digital twin can be used to simulate the movement of people in the city. In this example, we look at different densities of people moving through the city from the subway. The constrained areas become very easy to see here. Movement of people can also be analyzed using real but anonymized information from billions of points of GPS, cellular, connected cars, Bluetooth, ticketing, demographics, and ground truth data to paint the richest, most complete picture of the moving population. And these are just a few examples how digital twins are being used today to drive new insights from decision makers and stakeholders. But to make the most effective use of digital twins requires more than technology. It requires a culture that puts an emphasis on data-informed decision making and business processes that leverage infrastructure digital twins. The digital twins are not just about 3D models and images. It's all about the data. And it's about thinking differently on how you develop workflows to leverage the digital twin. And one thing that I didn't mention explicitly is our commitment to openness. Open standards, open source software, and open data. And Bentley has contributed the platform for using and integrating infrastructure digital twins into your own applications to the open source community. It's called iModel.js and you can find it on GitHub. In summary, the digital twin is built upon an open and connected environment. It provides access to trusted information. It can be used from planning to operations for a variety of workflows supporting smart city initiatives. Thank you for watching. My name is Tom de Vries and I work for Bentley Systems.